Okay, this is Mr. Taberi. Today we're going to take a look at digital multimeters. So I have two meters set up right here. The first one on the left is a Fluke 23. This is an auto-ranging meter. And then the one to the right is a Craftsman manual ranging meter. Now, the two will vary in price. The Flukes are generally more expensive than the Craftsman meters. This meter is right around $150 to $250 depending on where you get it. This multimeter over on the right, the Craftsman, is we picked it up for about $22. So both meters are capable of reading volts, amps, and ohms, and we're going to talk and discuss different features of each meter. So the first meter we're going to discuss is the Fluke 23. Alright, so here we have our Fluke 23 meter, our auto ranging. So a couple of things we're going to take a look at first. First off, our leads. We have two leads, okay? You have a negative lead and a positive lead. And in our leads, what you'll notice is on my positive lead, I have this fuse that I wired up in series with that lead. The reason I did this is for when we measure current. This typical automotive fuse that sits right inside of this pocket, this one will generally break before the fuse inside of the actual meter breaks if I hook it up wrong. So it's a worthwhile thing to do, and they do sell meter leads that already have these fuses connected. So I would highly recommend performing this, even if you're a professional, because when you burn up a fuse internally inside of the meter, they're awfully expensive and they can be time consuming to replace. Whereas if you're on a job and time is of an issue, replacing these fuses doesn't take very long at all. So it's just a standard 10 amp automotive fuse. Now our leads that go into the meter, they connect into these two places. Now right down here, your black lead is always going to go into the COM or common port. So you'll always see it'll be black and it'll have COM on there. So that's where your negative lead is always going to connect to. Your positive lead, if you're measuring volts, ohms, or resistance, your positive lead is going to go into the V, omega, and that little symbol right down there, and that's a diode. So for diode checking. So if you're measuring volts, ohms, or diodes, put the positive lead in this terminal. Okay? And we'll discuss these other two terminals in a minute. Now, taking a look at this auto range meter, okay, if I wanted to turn it on, if I wanted to measure volts AC, that would be our first selection. And that's the volts with the squiggly line above it. Okay? The squiggly line represents alternating current, okay, or AC. For standard automotive use, we're not typically going to use this unless we're checking for AC ripple voltage coming off of an alternator. But for the most part, we're going to use the volts DC, and that's indicated by the straight line with the dotted line underneath. So that's volts direct current. Okay, and if you're not sure, you can just switch between the two and the meter will actually display what type of voltage you're reading. So if you're on AC, it'll say volts AC, DC, volts DC. Okay, the next scale is a 300 millivolt scale. So if you're measuring very, very, very low voltage, you want to stick with the 300 millivolt scale. So that's 0.3 volts and lower. So what this means is if you try to read battery voltage on a car and you're on the 300 millivolt scale, your meter will not read it. Okay? The reason being is because an automotive battery is 12.6 volts, which far exceeds 300 millivolts or 0.3 volts. Okay? The next scale is our ohm scale. This is for measuring resistance, so identified by the omega symbol. So once you're in the ohms, you can go ahead and measure the resistance of whatever object it is that you're measuring, whether it be a light bulb or resistor, okay, a motor, or even a horn. So you take your two leads, go directly to the load as long as it's not connected to power, and we'll cover that later. Now you'll notice on the screen it displays OL. My two leads are currently not touching anything. The OL stands for over limit, which means the resistance between the two leads exceeds the resistance the meter is capable of reading. And this meter is capable of reading up to about 20 million ohms. So that means the resistance between these two leads is more than 20 million ohms, which makes sense because they're not touching each other. The next one in series, we come down here. So the next setting is diode check and then continuity. And you'll notice there's this really kind of wavy looking thing, and that's an audible signal. So that means if there's an electrical connection between a wire or a piece of metal, it'll signify that it has a good connection by producing an audible beep. So this could be demonstrated by taking both of our leads and touching them together. So if you want to find out if a wire has a good connection from one side of the vehicle to another, disconnect the wire from each end and then put your continuity tester up to it. If you get an audible beep, that means you have a clean connection from one side to the other. Okay, and electricity should be able to travel through it. We also can use this to measure diodes, because it should beep in one direction and then not beep in the opposite direction. If you're testing a diode and it beeps in both directions, the diode has failed. Okay. The next scale that we have is amps AC. So this is measuring AC current. So signified up here on the top, you have the AC signal. And then the last one is amps DC for direct current. When working on an automobile, you're going to spend the majority of your time, if you're measuring current, under the amps DC. Now, when you're measuring current, if you're in either of these two positions, you have to make sure that you take the meter lead's positive lead and you have to switch it over to the 10 amp or to the 300 milliamp socket. So right here, typically what you're going to use is the 10 amp. So now your meter is set up to read current. Okay? Now it's important to note that when you're done measuring current, you need to take this positive lead, pull it out of the amp scale, and put it back over here in the volt scale. Alright, so the next thing we're going to take a look at this meter is this gray button that's right in the middle. So if I take my meter and I put it over here on the voltage scale, we'll go to volts DC. Alright, what you'll notice is when I hit this button, there's going to be a small circle with a dot in the middle of it. And that means you're removing the meter from the auto range scale. So at this point, if I was to measure voltage, DC, I can't read above 0.999 volts. Okay? Because the meter will stop reading and it'll just establish an OL for over limit. If I hit the button again, I shift the decimal to the right one place. Now the maximum voltage I can read is 9.99 volts DC. Okay? It won't read anything higher than that. Hit it one more time. Now we can go up to 99.9 volts DC. Again, we can't read anything higher than that. Now we can read as high as 999 volts if the meter goes that high. Now, this can be frustrating because people can accidentally hit it, and then every time they go to read something, it comes out with over limit, or you get just some really strange meter reading. So my tip to you is, if you see this circle with the dot, go ahead and push the gray button and hold it down. Once it goes away, now we're back into the auto-ranging scale. So just make sure that whenever you're measuring something, you identify any form of prefix that's over here on the right and apply it to your reading to put everything into base units. Now, to give you an example of the auto-ranging feature, we're going to take a look at measuring the resistance of this light bulb. Okay? We've got two terminals on this light bulb, so I'm going to take both of my leads and I'm going to set them up to the bulb and then measure the resistance. First I'm going to set my scale to the ohm scale. Okay, so right now we're OL because our two leads are trying to measure the basically the resistance of air, but that's obviously very difficult to do, so hence it's over limit. So now what I'm going to do is I'm going to go ahead and attach them to my light bulb, and we'll see what sort of resistance we get. Alright, so my light bulb is roughly 4.8 to 4.7 ohms. So you'll notice that the meter is going to fluctuate up and down. So sometimes you get lucky and it stops, just like this, but sometimes it'll just keep going up and down. If that's the case, just kind of round it. But we got 4.7 ohms on this light bulb. That's the resistance of this light bulb. Now without touching anything on the meter, I'm going to go back and I'm going to take my hands and I'm going to touch both of these leads and I'm going to measure the resistance of my body. So right there, I'm right about 1.4 mega ohms. So note the prefix over on the far right. Okay, you see that uppercase M? So what that means that I have to take my reading and I have to multiply it by 1,000,000. So right now my body's resistance is ranging from 1,000,000 to 900,000 ohms. Okay, and then if I let go, it goes right back to the over limit scale. Okay, so the auto ranging feature is really nice because it allows us to vary that, and we don't have to do a whole lot of work. Okay, so that's an auto ranging meter. Next up, we're going to take a look at a manual ranging meter. Alright, so right here we have a manual range meter. We could take a look at it. It's got a whole bunch of scales all the way around this circle. Okay, the straight up position is the off position. If we want to go around the scale, which we'll do, we'll take a look at the first one is VAC. Okay, so I'll try to zoom in a little bit here. So the first scale is volts AC. You have 600 volts AC. So that's the maximum amount of voltage AC that we can measure with this meter. The next one is 200 volts AC. So if I have something that's 250 volts AC, or if I'm trying to measure a 220 single phase outlet, this will not work because the scale is too low. I would have to use a 600 volt AC scale. Okay. The next scale is amps AC. Now this part is very similar to the fluke meter in regards to down on the bottom with our two leads. We would have to switch those. So I'm going to come back to that. And we have the 10 amp scale, 200 milliamp, and then a 10 amp scale DC, and then right over here we have battery. So this is designed to measure AA, AAA batteries, and then also 9-volt batteries. So it's a very specific scale for those. So it just makes it so that when you measure it, you're very accurate. Just like on the fluke meter right here, we have a diode check and we have an audible signal. So when my two leads touch, we can measure for continuity. So hence this is referred to as a continuity test. So we take our two leads, and we touch them together. So we can determine if we've got a good connection. You can use this for bare metal grounds on chassis, but I like to use it primarily just for wires. It tends to work out pretty well. The next one is your resistance scale. Now for this one, this is our ohm scale. So right now we're on a low ohm 200 ohm scale. So I always refer to that as low ohms. You can register all the way up to 200 ohms, but not over. The next scale is 2000 ohms. Then we have a 20K for 20 kilo ohms. So that'll measure 20,000 ohms. Then you have a 200K, so that'll register 200,000 ohms, but nothing higher than that. And then you have a 2000K, so this meter is capable of measuring up to 2 million ohms, but not higher than that. The next scale we got is volts DC. So we have 200 millivolts, and then we have 2000 millivolts. The next scale up is 20 volts DC, and this is the most preferred setting that you're going to be on if you're working on an automobile. Okay, because the majority of electrical circuits that are in our car are 12.6 to 14.6 volts DC. Then you have the 200 volt DC, and then we max out at 600 volts DC, and then back to the off position. So your cheaper meters are going to typically look like this. It's not to say that they're not worth buying. They work very well. You just have to know how to appropriately use them and how to set the scales. So now we're going to take a look back. I'm going to just show you real quick our meter lead change if we're going to measure current. We're going to stay away from this section, which is amps AC, because we don't necessarily need to do that, because all the current that we're going to measure in the automotive industry is going to be DC, for our purposes anyways. So right here we're on the 10 amps DC scale. We take a look at our meter leads down here on the bottom. The red lead is in the volt, ohm, and milliamp position. And what that means is, if I was registering 200 milliamps DC, I could just leave these leads where they're at, and it'll register that current. Okay? But most of the time you're going to be in the 10 amp scale if you're measuring current. So what you want to do is select the 10 amp scale, take your positive lead, pull it out of the volt ohm position, and then shift it over here to the 10 amp position. And now you're ready to measure current. Okay? So now we can register all the way up to 10 amps. Now, just like the Fluke, I did the same thing, and I wired a fuse, an automotive fuse, into the positive lead. So yet again, we do not have to change the internal meter fuse. We could just change this fuse right here if we pop it by hooking up our leads to a circuit inappropriately. So I'm going to go ahead and pull this lead back out, put it back over here. Okay, now what we're going to do is we're going to take a look, and I'm going to show you the manual range when it comes to measuring resistance and what sort of readings you're going to get. So we're going to start by doing the same thing we did before. We're going to measure the light bulb, and we're going to measure our body's internal resistance. I'm going to turn the scale down here to the 200 ohm scale. Now what you're going to notice is on the cheaper meters, they will not display OL for over limit. So note my two leads are not touching one another, so they're trying to measure the resistance of the air, just like my other meter did. But you'll see that there's a 1 on the far left, and then there's a decimal a couple positions over. Okay, this is this meter's method for telling us it's over limit. Okay, so it's kind of goofy. It's kind of, you got to get used to that. Okay, So the first thing we're going to do is we're going to go ahead and we're going to measure the resistance of this light bulb again. So I'm going to take my 2 leads, go up to the 2 terminals on the light bulb as best I can. And there you go. So this one reads 5 ohms of resistance for this light bulb. Okay, easy and simple. So now what I'm going to do is I'm going to go ahead and I'm going to measure the resistance of my body. Now I'm going to take both my fingers, I'm going to touch these leads, and we're going to pay close attention to this screen on the meter. Notice how there's no change. Okay? That does not mean that your body is over limit. That just means that we're set on the wrong scale. So what you have to do before you give up on measuring resistance is you have to start from the bottom and work your way up. So we're going to click to the next scale, 2,000 ohms. Still nothing. Go to the next scale, 20,000 ohms. Still nothing. So my body's got to have resistance larger than 20,000. So now we're on the 200,000 ohms. Still nothing. Okay? And now we go to the 2 million ohms. And there you go. So now it's measuring my body's resistance, which is right around 700,000. Okay? So this is how we appropriately use a manual ranging meter. It is very effective. It is efficient. Okay? So just because it's cheap doesn't mean it's trash. So we can use it, we can get accurate results, and we can get them quick as long as we know where to put our settings at. Okay? If you're going to be a technician for a living and you do this every day as a career, my advice would always be to go with an auto ranging meter. Okay? So you don't have to keep fiddling around with this. You could just set it, read it, forget it. Okay? So, thanks for watching.